This is our first lesson on probability. So to review some things you may or may not already know about probability, if A and B are mutually exclusive events, so if you look over here, A and B are mutually exclusive, which means they're not going to occur at the same time, then the probability of A or B happening is equal to the probability of A plus B. The probability of A and B occurring at the same time is 0, because mutually exclusive by definition means that they're not going to happen at the same time. The complement of an event is the set of all outcomes in a sample space that are not included in the event. So if C is the event that A does not occur, then the probability of C happening is equal to 1 minus probability of A occurring. So that's how we find the complement. If A and B are independent events, then the probability of A and B happening is equal to the probability of A times B. That's important to know. All of these are very important to know, so I would write them down. If probability of A and B is equal to the probability of A times B, then A and B are independent events. So those two go hand in hand. Then if A and B are not mutually exclusive events, then the probability of A or B happening is equal to the probability of A plus the probability of B minus the probability of both of them happening at the same time. So all of these are going to be really important for all of Unit 12, especially this first section. So let's talk about the first example. So Allie spins the spinner and draws one card without looking. She gets a 3 on the spinner, and she gets a 3 for the cards. Then she sets the card aside, spins again, and draws another card. Is it possible for Allie to get a 3 on her second spin? It is possible, because on the second spin, we didn't do anything with this number 3. She set the card aside, but she didn't do anything with the 3 on the spinner. She didn't randomly just cut it out. So she can get a 3 on her second spin. It's not removed. On her second card, so can she get a 3 again on the second card that she pulls? And in this case, we have no, because number 3 card was set aside. So then for part B, how does getting the 3 card on her first draw affect the probability of getting a 2 on the second draw? So for the first pick, before she even picked the 3, the probability of getting any one of those numbers was 1 out of 4. So the probability of getting a 2 was 1/4. On the second draw, we got rid of this 3. So the 3 card's no longer there, which means that on the second draw, we only have 3 possible numbers, 3 possible cards she could pick. So that changes the probability from 1/4 to 1/3. So it makes her chances of choosing a 2 more likely. So now let's go to this example. So find the probabilities of mutually exclusive events. So again, things that can't occur at the same time. You roll a standard number cube once. So a standard number cube is like a die. So you could roll it and you could get 1, 2, 3, 4, 5, 6. Let E represent the event that you roll an even number. Let T represent the probability that you roll a 3 or a 5. What is the probability that you roll an even number or you roll a 3 or a 5? So let's write this out as probabilities. So the probability that you roll an even number, we're going to say P of E. So the probability that E, the event E, is going to happen. And then if we rewind back to the very beginning, or means that we're going to add these two probabilities. So the probability of T occurring. So we'll add these two, but first we need to figure out the probabilities. So a standard number die means that there are 3 even numbers on it. There's 2, 4, and 6. So that's 3 out of the possible numbers. The possible numbers that you could get, there's 6 different ones. So 3, 6 plus the fact that you roll a 3 or a 5. Well, if you roll a 3 or a 5, that's 2 numbers out of the 6 numbers. So then we're going to add these two and we get 5, 6. So the probability that you roll an even number or roll a 3 or a 5 is 5, 6. What is the probability that you roll an even number and a 3 or a 5? So think about that. Rolling an even number means that you rolled a 2, a 4, or 6. Can you roll a 2, a 4, or 6 and a 3 at the same time? Or roll a 2 or 4 or 6 and then a 5 at the same time? This is 0 because the even numbers and the 3 or the 5 are non-overlapping events. They can't happen at the same time. 3 is not even. 5 is not even. So it's never going to occur at the same time that you roll an even number and a 3 or a 5. So that is going to be 0. What is the probability that you do not roll an even number? Well, if you don't roll an even number, you're going to roll an odd number. So the probability that you roll an odd number, there are 3 odd numbers on a standard die, 1, 3, and 5. So that's going to be 3 out of 6 possible numbers. So our probability is 3, 6. And now you guys are able to try some of these on your own.